In this video, let's look at the effect of an equilibrium by an inert gas, temperature, and a catalyst. We'll start with an inert gas. When an inert gas is added to a system at constant volume, there is no effect on the equilibrium. But when an inert gas is added at constant pressure, which means our volume needs to increase, the equilibrium will shift to the direction with a greater number of moles of gas. So these are the two statements you need to keep in mind when you're looking at an inert gas. How about temperature? So, unlike earlier effects, the effect of temperature not only changes the equilibrium position, but it will also change our equilibrium constant K, because K depends on temperature. So one of the things we have to look at in our particular equations is if we have nitrogen plus 3 hydrogen gas in equilibrium with 2 NH3 gas, we have to look at some of the and consider the thermodynamics of this equation. Our delta H here is negative 92 kilojoules. Okay, if it's negative, we're going to have an exothermic reaction, and that means that heat should be listed as a product. Therefore, if we increase the temperature, we're going to increase the amount of heat that we have, and that's going to shift the equilibrium to the left. If we decrease the temperature, that'll shift the equilibrium to the right. If we have an endothermic reaction, the reverse will be true, because in an endothermic reaction, heat is going to be a reactant and not a product. So then lastly, if we look at the effect of a catalyst, we can say that a catalyst speeds up a reaction, therefore it has no effect on the direction of the equilibrium. So these are the effects that we're going to look at and kind of analyze them in the lens of Le Chatelier's principle, and you'll be responsible for knowing how equilibria are influenced by each of these effects. And in the next couple videos, we'll go through several example problems of calculating equilibrium constants, having equilibrium manipulated, and we'll kind of wrap up this chapter so we're prepared to solve some of the problems that we're going to do in the next couple chapters involving acid-base and manipulating equilibrium expressions.